Section 1. A World of Surprises. Redefining the Frozen Continent. Think of Antarctica, what comes to mind? A vast, endless expanse of white, a silent, frozen desert at the bottom of the world. For generations, this was our collective image of the continent. But what if I told you this image is profoundly incomplete? What if this seemingly static world is, in fact, one of the most dynamic and surprising places on our planet? New discoveries are peeling back the layers of ice, and underneath, we are finding a world more complex, more active, and more connected to our daily lives than we ever imagined. The Antarctica of our imagination is giving way to the Antarctica of reality. Our old ideas are melting away, much like the ice itself. We once thought of Antarctica as a simple, stable block of ice, a passive bystander in the Earth's climate system. But that picture is being redrawn, pixel by pixel, with every new satellite image and every deep ice drill core. We are learning that this continent is not just a featureless slab of ice. It is a geological marvel, hidden mountain ranges taller than any in Europe, vast liquid lakes that have been sealed from the world for millions of years, and even active volcanoes generating heat deep beneath the frozen surface. It is a place of constant change and hidden drama. The story of Antarctica is no longer just a story about ice. It is a story about hidden water, hidden land, hidden life. Section 2. Under the ice, hidden lakes, rivers, mountains. Imagine a lake, larger than some of the Great Lakes, buried under 2.5 miles of solid ice. This is not science fiction. This is Lake Vostok, the largest of over 400 known subglacial lakes in Antarctica. For millions of years, these lakes have been completely isolated, sealed in total darkness under the immense pressure of the ice sheet above. The water in them stays liquid because of the insulating blanket of ice and the subtle geothermal heat rising from the earth below. For a long time, scientists wondered if anything could possibly live in such an extreme environment. Perpetually dark, incredibly cold, very few nutrients. Yet, when researchers carefully drilled down and sampled the water from some of these lakes, they found evidence of life. Not fish or plants, but microscopic organisms called microbes. These are single-celled life forms, some of the toughest survivors on our planet. It is not just lakes that are hidden down there. Recent surveys using ice-penetrating radar have revealed entire networks of rivers and streams flowing at the base of the ice sheet. These subglacial river systems can be hundreds of miles long, carving channels into the rock, transporting vast amounts of water from the interior of the continent towards the ocean. Section 3. Fire and Ice. The Unseen Volcanoes of Antarctica. When you think of volcanoes, you might picture tropical islands like Hawaii or the dramatic eruptions of Mount Vesuvius in Italy. You almost certainly do not picture Antarctica. Astonishing recent discovery. The continent hides a massive volcanic system, with nearly 100 volcanoes buried beneath the West Antarctic ice sheet. This is the largest volcanic region on Earth, a land of fire hidden beneath a land of ice. These subglacial volcanoes sit in a vast rift valley system where the crust is being stretched and pulled apart. That process lets magma from deep within the Earth rise closer to the surface. Most aren't spectacularly erupting, but they release significant geothermal heat. The heat warms the bedrock under the ice sheet, like a giant heating pad under a block of ice. It melts ice from the bottom up, creating lubricating water in subglacial rivers and lakes. This volcanic heat adds a critical piece to the Antarctic ice loss puzzle. Modelers now must account for this internal heat source. An eruption under the ice wouldn't necessarily blast through the miles above. Instead, it would create massive meltwater at the base. That sudden flood could dramatically accelerate glacier flow, acting as a trigger for rapid, widespread changes. The silent, frozen continent has a fiery secret. Section 4. Life in the Extreme. Finding biology in the dark and cold. Life as we know it is fundamentally powered by the sun. Plants use sunlight to create energy. Animals eat the plants. Animals eat other animals that ate the plants. It is a chain that starts with light. So what happens when you go to a place with no light at all, like the seafloor under hundreds of feet of floating ice miles from the open ocean? For a long time, the scientific consensus was not much. That expectation was shattered by a shocking discovery made by scientists from the British Antarctic Survey. They were drilling through the Filchner-Ronne ice shelf to collect sediment samples from the seafloor below. When they lowered a camera down the borehole, they were not expecting to see any life on the boulder they hit, but there they were. Attached to the rock were strange stalked creatures that looked like sponges, other filter-feeding organisms. This was 160 miles from the open sea, in total darkness, with water temperatures below freezing. It was a place where, according to all our theories, complex life simply should not be. And yet, there it was. This discovery is profound because it breaks our rules for where life can exist. If life can exist in such an extreme, isolated, and nutrient-poor environment on Earth, it makes it more plausible that life could exist in similar environments elsewhere in the solar system. Section 5. Ghosts of the Past: Fossils, Forests, and Cosmic Dust. The ice of Antarctica is more than just frozen water. It is a library of ancient history. By drilling deep into the ice sheet, scientists extract long cylinders of ice called ice cores. These cores contain tiny bubbles of air that were trapped when the snow fell, sometimes as long as 800,000 years ago. These bubbles are perfect little time capsules. By analyzing the air inside, we can measure the exact composition of Earth's atmosphere from the distant past. We can see how much carbon dioxide, methane, and other greenhouse gases were in the air. This gives us a direct record of how climate has changed over hundreds of millennia. The ice cores show us that the levels of carbon dioxide in our atmosphere today are higher than they have been at any point in the last 800,000 years. And the speed of this increase is unprecedented in the entire record, but Antarctica's history goes back even further than the ice. Before it was a frozen continent, it was a green one. Millions of years ago, when the continents were arranged differently, Antarctica was part of the supercontinent Gondwana and was located in a warmer part of the world. Scientists have found stunning evidence of this lost world. In the mountains that poke through the ice, they have discovered fossilized leaves, pollen, and even entire tree stumps. Antarctica is also a surprisingly good place to find treasure from outer space. The continent acts as a giant collector for meteorites, which are rocks that have fallen to Earth from space. Teams of scientists can then travel to these meteorite-stranding surfaces and simply pick them up. These rocks from space are pristine samples of the early solar system, giving us clues about how planets, including our own, were formed. Section 6. The moving ice glaciers on the brink. Not all ice in Antarctica is the same. Much of it is part of the vast, slow-moving ice sheet in the interior, but at the edges, the ice forms massive rivers called glaciers. These glaciers are the continent's arteries transporting ice from the high interior down to the ocean. And some of these arteries are flowing faster than ever. One glacier has become a focus of intense scientific scrutiny: Thwaites Glacier in West Antarctica. It is so large and its potential for collapse so significant that it's nicknamed the Doomsday Glacier. The nickname is dramatic, but it's a serious concern. Thwaites is about the size of Florida and it acts like a cork in a bottle, holding back even more ice. Recent research has delivered shocking discoveries about its stability. Using underwater robots and satellite data, scientists found warm, salty ocean water circulating beneath the glacier's floating front, the ice shelf. That warm water is melting the glacier from below, carving out huge cavities, and weakening its hold on the seafloor. One cavity was 2/3 the area of Manhattan and hundreds of feet high. This melting is forcing the grounding line to retreat. The grounding line is where the glacier lifts off the bedrock and begins to float. As it moves inland, more base is exposed to warm water, creating a dangerous feedback loop. Worse, the bedrock beneath Thwaites slopes downward inland, so retreat means the glacier sits on deeper ground, which can make it unstable and flow faster. This is called marine ice sheet instability. The fate of Thwaites and neighboring glaciers is a major uncertainty for future sea level rise. If it collapsed completely, global sea levels could rise by several feet. That may not sound like much, but it's enough to inundate coastal cities and communities worldwide. The rapid changes at Thwaites are a wake-up call. They show ice sheet responses may not be slow or linear. There could be tipping points, rapid, irreversible changes on human timescales. Section 7. A global connection: oceans, weather, and us. What happens in Antarctica does not stay in Antarctica. This remote continent is deeply connected to the rest of the planet through the vast circulating currents of the global ocean. Think of it as the heart of the world's ocean circulatory system. Near the Antarctic coast, a unique process takes place. When seawater freezes to form sea ice, it leaves behind very cold, very salty, and therefore very dense water. This super dense water sinks to the bottom of the ocean, forming a current known as Antarctic bottom water. This current then spreads northward, carrying oxygen and nutrients along the seafloor into the Atlantic Ocean, Pacific Ocean, Indian Ocean. This process is a fundamental driver of the global ocean conveyor belt. It moves heat around the planet, much like our own circulatory system moves heat around our bodies. It plays a huge role in regulating global climate. However, new discoveries show that this vital process is being disrupted. As the Antarctic ice sheet melts at an accelerating rate, it releases enormous amounts of fresh, buoyant water into the Southern Ocean. This fresh water dilutes the salty surface water, making it less dense and less likely to sink. As a result, the formation of Antarctic bottom water is slowing down. A slowdown of this deep ocean circulation could have far-reaching consequences. It could alter weather patterns across the globe, changing where it rains and how strong storms become. It could reduce the amount of oxygen delivered to the deep ocean, creating stress for marine ecosystems. And because this circulation helps pull carbon dioxide from the atmosphere into the deep ocean, a slowdown would mean that more of the carbon dioxide we emit stays in the atmosphere, potentially accelerating global warming. The most direct connection, of course, is sea level rise. Every gallon of water that melts from the land-based ice sheet in Antarctica and flows into the ocean adds to the total volume of the world's seas. For coastal communities everywhere, Miami, Mumbai, New Orleans, Shanghai, this is not an abstract concept. Section 8, The View from Above, How New Tools Reveal Old Secrets. Our ability to make these mind-blowing discoveries in Antarctica is not an accident. It is the result of a technological revolution in how we study our planet. For most of history, Antarctica was a blank spot on the map, its interior a mystery. Today we have an armada of sophisticated tools that allow us to see the unseen and measure the unmeasurable. Chief among these are our eyes in the sky, satellites, orbiting hundreds of miles above the Earth. They are our tireless sentinels, watching over the ice day and night in all weather. Some satellites like NASA's IceSat-2 use lasers to measure the height of the ice sheet, with incredible precision, down to a fraction of an inch. By comparing measurements over time, we can see exactly where the ice is thinning, and by how much. Other satellites like the GRACE-FO mission do something even more remarkable. They weigh the ice sheet from space. They measure tiny changes in Earth's gravity field. As the ice sheet loses mass, its gravitational pull weakens slightly. These sensitive satellites can detect that change. This gives us a direct measurement of how much ice Antarctica is losing each year. To see what is happening beneath the ice, we send out airplanes with ice-penetrating radar. The instruments send radio waves down through the ice and they bounce off bedrock and return. The return time tells us the thickness of the ice. Flying back and forth in a grid creates detailed 3D maps of hidden mountains and valleys. For the world beneath floating ice shelves, we now have autonomous underwater vehicles, AUVs. These robotic submarines go into dark, dangerous cavities under the ice. Cameras, sonar, sensors. They measure water temperature, salinity, and currents. Section 9. The Future of the Ice. A story of warning and hope. The flood of new discoveries from Antarctica tells a complex story. It is, without a doubt, a story of warning. The data is clear. The ice is changing and it is changing faster than we thought possible. The sleeping giant at the bottom of the world is waking up. The retreat of glaciers like Thwaites, the slowdown of deep ocean circulation, and the confirmation of widespread melting from below are not distant theoretical problems. They are real-time observations of a planetary system under stress, with direct consequences for global sea levels and climate stability. The evidence etched in the ice cores reminds us that our current path is taking us into uncharted territory. But this story is not just one of doom, it is also a story of hope and human ingenuity. The very fact that we know these things is a triumph of science and international collaboration. In one of the harshest environments on Earth, scientists from dozens of countries work together, sharing data and resources to piece together this complex puzzle. This spirit of cooperation is a model for how we can tackle global challenges. Knowledge is power, and these discoveries give us the power to understand the risks we face. They replace vague fears with concrete data, allowing us to make better predictions and plan more wisely for the future. The science is telling us that the future of the Antarctic ice sheet is not yet written in stone. While some amount of future sea level rise is now locked in due to past emissions, the worst-case scenarios are not inevitable. The speed and scale of future ice loss depend critically on how much warmer our planet gets. The discoveries of tipping points and feedback loops are not reasons to despair. They are reasons to act with greater urgency. Ultimately, the secrets of Antarctica are a reflection of ourselves. Antarctica is a place of profound beauty, mystery, and power. It is calling on us to be curious, to be wise, and to be courageous. The more we listen to the stories it has to tell, the better we can become as stewards of this remarkable blue planet we all call home.